Great. Welcome, everyone. I'm Hani Mohammad. I'm director of the Northwestern University Transportation Center, and I am also the holder of the Patterson Chair in Transportation. And in that capacity, I have the privilege of opening this annual event, which is our Patterson Distinguished Lecture, which has been set up to honor William Patterson, former president and CEO of United Airlines, in whose honor the Patterson Endowment was set up at Northwestern. This year, we will be celebrating our 41st annual Patterson Lecture, which honors a leader in industry. And this year, we have a very special one and a very good friend of the Transportation Center. To introduce him, I'm very pleased to have the chair of our Business Advisory Council and a former Patterson speaker himself, Jeff Silver.
Thank you, Hani. 41 years, so Doug was probably at that first one, I think, right? Just kidding. Old people jokes. So Hani emailed me the other day, or Brett, I forget whom, and asked whether I would be comfortable introducing Doug tonight. And I said, sure. That's fun for me. I've known Doug for a little while, 15, 20 years, I'm not sure. And you can read about Doug in the little pamphlet you got, so I'm not going to talk about what his career has been, but you can read that, right? So I'll talk about other stuff about Doug that I may know. I might make up some of it. Some of it he might have told me when 2 weekends ago we were in Napa drinking a lot of wine together. But there's a lot of pieces of Doug that you might not expect from a guy that's running a transportation company. He still plays in a band. He's got a couple of kids that are wrestlers. He is an aerial stunt pilot, and that is super relevant if you think about what he has dealt with over the last decade or a little bit more of running Echo Global Logistics, having been the guy to take it public and deal with a public life and do a lot of twists and loops up in the air while he was trying to do that, and then being able to land it and not be public anymore, and has a giant smile on his face now. So I don't know if that's a story that he's going to tell us this evening. I sort of hope it is, but I'm not sure. But if you look at Doug right now, he's smiling. If you looked at Doug 3 years ago, he wasn't smiling as much. So, but he's been the leader of Echo for a long time, through thick and thin, and has done a great job with it. And if you look at the folks that are with him tonight, that would do anything for him, I think it's a testament to what he's built over there, continues to lead it, and he's done a great job with it. So with that, here's Doug.
Good evening. I'm not sure how Brett and Hani got me to do this, but here I am. As an introvert, most people don't think CEOs are introverts, but many of them are, and I'm in that club. I was talking to my wife. I was a little nervous about talking to this big group tonight, and she said, "Don't worry, honey. I'm sure you can do better than the President of the United States." Maybe even the Vice President. I asked Hani what he wanted me to talk about, and he said, "Whatever you want." So I thought, okay, I should pick something that's I'm passionate about, and it didn't take me long to come up with technology. I'm not really a technologist. To start off in sales, I worked in operations. I did get involved with technology along the way in my career, but I've always had a passion for technology and the role that it could play in this industry. And my first interest in computers and technology really goes back to when I was in college. And if you've ever, I'm sure you've all had some moment in your life, a small conversation that made an impact on you, and a light bulb went off. And for me, as it relates to technology, it was when I was in college. I was an econ major with an emphasis in econometrics. So that meant I took a lot of math and statistics classes, and we would create models to try to predict things. And I was a TA for a professor, and in addition to grading exams, I would help him with a research project, and he was consulting for San Diego Gas and Electric. And so I had an assignment of working on some demand models trying to predict electricity demand. So I had come up with this nonlinear multiple regression model that had 10 independent variables, and I can't remember, a couple thousand observations of data. And you have to run that through a computer because the math is very simple, but it's very tedious and very iterative. So, in those days we had time sharing, so you had to sign up for a time slot to use the computer because the entire California State University system shared one computer. And so I ran the job and sat down with my professor to go over the results. And a thought occurred to me. I said, if I were to do this by hand with a calculator, how long do you think it would take me? And he thought for a second. He goes, probably about a week. And I said, a week? And he said, yeah, if you didn't sleep. That statement, all these years later, and I've been in the industry now for 43 years, it just stuck with me, the power of computers and what it is enabling us to do. So much so that I decided to get a minor in computer science, but in those days, that wasn't a big deal. I think I had to take 3 classes. One was a Fortran class, one was a basic class, and one was a general CS class. And I would say that the average 8th grader in a STEM program knows more than I did when I got my minor in computer science. But I got out of college and I went to work for a trucking company. And the trucking company I went to work for was McLean Trucking Company. Some of you guys might remember that. They were the 4th largest LTL carrier at the time. And they were a carrier that had a management training program. They were really ahead of their time. In those days, most people in the trucking industry were middle-aged white men that smoked and drank a lot. And most of them didn't go to college. They started out as truck drivers. And McLean had this vision of bringing young people into the industry out of college and putting them through extensive training. So I had a 6-month training program before I ever started my job. And I'm going to take a commercial break for a moment and just address the students in the room. If you're a student, raise your hand. Well, at Echo, we hire about 60 people a month, most of them right out of college, so call us if you're looking. But more importantly, what I would tell you is, I'm going to echo the words of Jeff Silver, this is a tremendous industry. I address every class of students that joins us each month, and I give them the same speech, and I say, it's not a sexy business, but it's a vital business. Everything that you own has been on a truck, a ship, a plane, a train, or some combination of all of those things. It's a huge industry. It's 10% of GDP. There's many different niches, and it's a great place to form a career, and there's lots of opportunities. So if you're interested in a career in transportation, I would strongly encourage you to pursue that. And being at an event like this and networking with the people in this room is a great opportunity for you. So back to my story. So I got a job with McLean, and after training, I actually got to drive a truck for the first 3 weeks. They thought it was important that everybody in management or sales understood what truck drivers went through. So I got to drive a truck. That was kind of fun. I started in sales, and some of the younger people may not believe this, but we didn't have cell phones, and we didn't have email. And so I would be out in my sales territory, and if I didn't have enough quarters in the ashtray, I'd have to stop at the bank and get a couple of rolls of quarters so that I had enough quarters to make phone calls throughout the day at a phone booth whenever I needed to do that. So The first big advancement in technology that I witnessed in the transportation industry was the invention of pagers. You know, the first pagers, all they did was beep. But the high-tech pagers had a little red digital readout on them, and whoever was on the other end, if they had the right equipment, could send you a number. And so, you know, we had a code in the office, you know, if it's 1, call the office. If it's 99, call right now because it's important. You know? And so I thought that was a huge advancement. A couple of years later, I got promoted to a terminal manager job. I went to Stockton, California. I started out in San Francisco, but I went to Stockton, California, and I ran a little podunk terminal that had 4 drivers and an office clerk, and I did the sales, and I also ran the terminal. And that was my first exposure really to the back office of the business and the systems and the paperwork, and I had a P&L. I want to take a moment just to describe the state of the industry back then. This would have been I graduated from college in 80, did 2 years in sales, so this would have been 1982. There was no technology whatsoever. We had the company had a mainframe system with green screen terminals, and all the system really did was provide a house for transactions, which we call freight bills. There was no rating in there, there was no tracking, there was no tracing. So imagine this, a customer calls you up and says, where's my shipment? Well, what day did you ship it? I shipped it on the 3rd. Okay, well, do you know a pro number? No, they don't have a pro number because in those days we didn't give them the pro number. So we would say, how many pieces were in the shipment? They said, well, it was three pallets. What did it weigh? It was 1,500 pounds. And where was it going? It's going to Nashville. So we literally walk over to a file cabinet, open it up, look for the folder that was marked April 3rd, pull that out, and there would be manifests from all the freight that our drivers had picked up, and they would be written on a manifest, and they would go with the trailer to the destination. And you'd look down there till you saw the pieces and weight that matched what they told you on the phone, and then you would say, okay, we sent this trailer to Kansas City. So then you get on the phone, you call Kansas City, and you'd say, is trailer number 1234 arrived yet? And if so, have you unloaded it? And can you find this shipment? Is it on the dock, or did you load it somewhere else? So you could spend 30 minutes tracking a shipment, and it might take 4 phone calls before you could even call the customer back and tell them where their freight was. And then if they raised hell with you because it wasn't good enough, now you had to make more phone calls to try to expedite it and get somebody to actually do something. Like I said, we didn't have email. We had a teletype machine. So if you wanted to talk to somebody at another terminal, you type the terminal code, and then you could write them, you know, what looks like an email today, but it would type out on one of those big printers, and it would print in their office, and somebody would be tearing off all the messages and passing them around to all the different people. And that was the state of the art. About that time, personal computers were hitting the market. So with my keen interest in computers, I bought one. My first computer was a Texas Instrument TI-99. I have to write this down because it had 64 kilobytes of memory, so that's 64,000 bytes. I'm going to give you a visualization of that in a minute. It didn't have a floppy drive. It was $600 for the computer, and there was no monitor and no drive. So if you wanted a monitor, you plugged it into the TV, and if you wanted a drive, there was another $600 expense for a floppy drive, which held a 5.25-inch floppy that held actually in the early days, 100 kilobytes of data. Later on, they expand to a megabyte. So I want to contrast that with the MacBook Pro that I bought 2 weeks ago. The original, well, I got the TI, and then I outgrew that pretty quick, and then I got an Apple IIe. Both of them had 64 kilobytes of RAM, 64,000 bytes. A byte is more or less 1 alphanumeric character. So if you take 64,000 characters, that's what could fit in the computer's memory when it was turned on. A piece of paper will hold about 3,500 characters. So if you divide 64,000 bytes of memory by 3,500 characters on a page, the entire memory of that computer would fit in 18 pages, which would be, you know, a 1/4 inch thick, probably less than that. My MacBook Pro that I got a couple weeks ago has 16 gigabytes of memory. If you perform the same math, instead of 18 pages of memory, you have 4.6 million pages. And instead of being a quarter-inch high, it will be 1,509 feet high. So we've come a long way. In fact, the memory grew by a factor of 250,000x. And if you look at hard drive storage, it's even more dramatic. If you take that 1 meg floppy drive and compare it to my 1 terabyte hard drive, it's 10 million times more capacity. And that stack of paper that I described would be 93,500 feet high, or 18 miles. So we've come a long way. And, that's just a personal computer. The industrial strength stuff is a lot stronger. So, I don't want to geek out on you, but I think that's cool. So in the mid-'80s, we started to make some progress in transportation. One of the first big steps was automated tracking. So we actually were able to get the computer systems of that era to store a pro number, and then when trucks arrived and departed, we would log in the system, the arrival and departure times, and then you could tie that to the pro number that was manifested on the trailer, and voila, we had tracking. It was still kind of clumsy, but we could do it, and we thought that was revolutionary. I think UPS was one of the first ones to do it, and everybody else piled in. And I remember, being in sales saying, we've got great technology. You can track your shipment. All you have to do is call us, and we'll put it in the computer, and we'll tell you where it's at. And we thought that was a pretty big deal. Later on in the 80s, we started to develop products for PCs because more and more businesses were getting them, individuals were getting them. So, one of the first things we came up with in the LTL business were PC rating products. So, in LTL, you've got this arcane system of classification and, weight and density and cube and all these factors that go into rating an LTL shipment. And, nobody understood it then, and they still don't understand it now. But, we put it all on a disk, so you put in your 2 zip codes, you put in your weight, your class, and voila, you get a rate. And again, we thought we were, rocket scientists, because we could give rates on a diskette, and people could run it on their PC. The next big increment in technology for LTL, and I think truckload was actually pretty far behind us, was a customer being able to use their computer via a phone line and a modem and connect to our computer to track a shipment. Does anybody remember the little 2400 baud modems? So that's 2400 bits per second of transmission speed. I checked yesterday at my home, and my internet connection was 250 megabits per second, so it was 104,000 times faster than those early modems. So we've come a long way. And then, of course, in the late 80s and the early 90s, we got the internet. And the internet was initially just sort of a fancy brochure. It didn't really do anything. There was no database connected to it. There were no JavaScript, to make pretty graphics. It was just text on a screen and some pictures. And then, over time, we started, as the tools developed for internet technology, companies started, doing a lot more with their website. In the 90s, something interesting started happening, which was the development of shipper TMSs. Some of you may know Mitch Wesley here in the room, but Mitch was really an early pioneer. I would call him one of the godfathers of TMS technology. In 1992, he created a company called Wesley Software. And it allowed a shipper to connect the TMS to their ERP system and gather shipments, put them in a bucket, sort through them, and look for ways to combine LTL shipments and make truckload shipments. I saw a demo about 1995 of the technology where they had it hooked up to a DuPont location that shipped a lot of LTL. And running this optimization, they were able to save DuPont $64,000 in one day by converting LTL shipments to truckload shipments. And so, again, I was amazed. And And so Mitch did well with that company. He eventually sold it to Red Prairie, and then Red Prairie merged with JDA, and then they changed their name to Blue Yonder. So it's old technology, but it lives on, and they continue to develop it. That wasn't enough for Mitch. After that, he developed another software system. He called it G-Log, and G-Log was sort of a fancier version of what he had created with Wesley software. G-Log was more aimed at companies that had global supply chains, that shipped internationally, had to clear customs, multimodal, those sorts of things. And he built that up and ran it for a few years, and he sold it to Oracle. And today it's called OTM. And I thought that, he was 2 for 2. But that wasn't enough. Mitch, a few years later, I don't know why anybody never made him sign a non-compete. But anyway, they didn't. He started a third TMS company called, of all things, 3G TMS. I think it stood for third generation. And he worked at that for a few years, and then he merged with a company called Transite and retired, and he's on their board now. But he made a lot of noise in the shipper TMS space, and today, those are 3 strong options, but there's a lot of other options as well. And for years, I would say that shippers lagged behind the transportation companies in technology, for the most part. The big shippers, the Walmarts and the 3Ms, those companies were very sophisticated. But for the vast majority, and in my company, we have 30,000 clients that we deal with. 99% of them have no technology. Most of them want it, but they can't get the budget internally in their firms to pay for it. So sometimes a third-party TMS is a solution, other times not. But just as there's shipper TMS technology, there's carrier TMS technology. And I would say that the state of the union for trucking company TMS technology is fairly abysmal. I'll quote something I heard Jeff say recently. Most large trucking companies are running mainframe computers with 50-year-old COBOL software, and it's true. I worked for Consolidated Freightways for a while. I worked for Yellow, and those companies ran big mainframe computers with software that was written in the 60s and 70s. And the good news about a mainframe computer is they're big, they're strong, they have huge memory, they have huge storage, they're reliable, they're dependable, but they're not really scalable. When you run out of room, you got to buy another one. And they don't have access to the sort of code and tools that we use today with more modern architectures. And for the small carriers, there was a product created. I hope I don't offend anybody here, but I'm just going to call it like I see it. There was a product called LTL 400. And LTL 400 runs on an IBM AS400, which is really old technology. And it was written in a software program called RPG. And today I would venture to say, and Jeff might be able to correct me on this, at least half of the LTL carriers out there still run their business on LTL 400. And it's got a green screen, and it's reliable, but you can't find software engineers that know how to write code in RPG. So the industry is in a dramatic need, I believe, the asset-based industry, for an upgrade of their technology. And I think, and this isn't a shameless plug for a friend, but I think Mastery's sort of in the right place at the right time with sort of the next generation software that can serve not only shippers and carriers, but brokers, and really anybody in the transportation ecosystem with modernized, cloud-based, service-oriented architecture, modular software. And the industry has a big need for that. What companies do, because when you're married to an old legacy system that you've invested millions and millions of dollars for years, it's hard to part with that. It's nearly impossible to replace it. And so as new technologies come along, as new features are requested, you have to figure out a way to build those and bolt them onto what you have, and it can be a little bit kludgy. So in the asset transportation world, there's a lot of sunk investment in technology that's getting long in the tooth, and over time it's going to have to get upgraded. In the non-asset world that I live in, when we started the company, we actually thought of ourselves as a technology company first. We're just going to make our money in freight. And so we have a whole different DNA than a trucking company. We've got an IT department with 330 people. We've got an annual budget of, this year we'll spend $70 million on technology. Now, two of our big competitors, and I'll say this because they've already said it publicly, J.B. Hunt, I think spends about $100 million a year on technology. C.H. Robinson spends $200 million a year on technology, and Jeff's holding up three fingers. That's a lot of money, but that's how we run our business. In the case of Echo, we move between 16,000 and 18,000 shipments every single day using other people's trucks. So to do that, you gotta have some technology. And if you wanna do it efficiently and actually make money doing it, you gotta have some technology. So I think the non-asset transportation community has really, and new, more sophisticated shippers have created demand for more technology, and the asset-based carriers are sort of dragging along. And sorry if I'm offending any asset-based carriers here. But I was an asset-based carrier for most of my career, so I think I can say it. So that's kind of the past. I want to step more into the present, talk about what's going on today, and I'll speak largely from the Echo context. There's a bit of a technology arms race right now, especially in the brokerage business and the non-asset logistics business. Every single year there's new startups, they're backed by venture capital, and it's actually fairly easy to build technology nowadays if you have a greenfield environment. I could go home tonight, I could spin up an instance on Amazon, have an AWS server, I can get a domain name, I can create a website, and have it all done before I go to bed. You can build technology today fast. What makes technology hard is when you have to integrate it to legacy systems that were written 10, 20, 30 years ago. And then it gets very, very complicated. So a lot of the non-asset transportation companies have had really the sort of the blessing of not having to have legacy systems and being able to start with a clean slate and use modern technologies and modern architectures that are easier and quicker and faster to build on. I was talking to my head of data science, who's sitting right in front of me, and we were talking about what's going on in the industry right now, and we agreed that it's about reducing friction. And he had a great analogy, I'm going to quote it. He said, it's kind of like the music industry. It used to be, if you wanted to find a song that you like, you'd listen to the radio. And if you heard a song you like and you wanted to hear it again, you kind of have to wait for the radio to play it again. And then, if you really liked it, you'd go to the record store and buy the record, or the CD, or the 8-track, depending on how old you are, cassette maybe. And then you'd take it home and play it, and every time you want to play it, you play it. Well, think about all the friction that we've taken out of that process. You no longer buy music, you subscribe to Spotify, you search the artists that you like, you can listen to the songs that you haven't heard, and when you like them, you add them to your playlist, and you can have every song in the world on your phone and listen to it at your leisure as many times as you want. So that's the definition of taking the friction out. And if you think about transportation, there's so much friction because it's much harder than playing music, right? We physically move goods through physical assets in multiple modes through infrastructure. And so there's a lot of work to do, and I think the industry is making good progress, but we still have a long way to go. I would say that today we're in the age of integration. When I think about the work that my IT organization is doing, a big chunk of it and the biggest backlog is integrating with other people. It could be a shipper who wants us to do automated quoting into their TMS. It could be a carrier who wants us to post loads so that they can take loads that fit their needs. It might be with a third-party technology provider. Visibility is a hot item right now, so it could be a 4Kites or a P44. Maybe we want to check somebody's insurance, so we got to connect with RMIS. There's all these new freight marketplaces. Everybody's probably heard of the DAT, but there's 4 or 5 new ones that have emerged. And so when you start thinking about how do we want to play in this ecosystem, what technology should we build and what should we buy or rent, because oftentimes that's the better decision, it generally requires integration. And not all integrations are created equal. You know, some people want to integrate through flat files, which is basically a big unstructured text file, and you have to parse it and figure out what's in there. Some people want to use EDI, which is a structured flat file, but nobody follows the structure, so you still have to interpret it. And then there's APIs, and you know that's the best way to do it, but you know there's a lot of work that goes in on both parties to connect those endpoints. So. I do think we're entering into a new age, though, of both hardware and software. I talked about, you know, the legacy mainframe systems. We went through a phase in the 90s and the early 2000s where we went to client-server technology. So rather than using IBM mainframes and connecting them to terminals, we started buying racks of servers and connecting them through the internet through web interfaces. And today we've got cloud computing. So you don't have to buy the racks of servers anymore. You don't have to buy the mainframes. You can create an instance on one of the cloud servers like AWS for Amazon or Azure for Microsoft and Google's cloud, and it's completely scalable. So if you create an application and it goes viral and every 18-year-old kid in the country wants to use it, you can log into your Amazon account and turn the dial, and your server gets bigger. And it can handle multiple users, and it's instantaneous. And you know that's how new software is being built. That's how Mastery is being built. That's how we're migrating our systems. You know, we even though we're a fairly young company, we were founded in 2005. The systems that we created in 05, 06, and 07, and 08, to us, are legacy systems, because the way you wrote code in 2007 is different than the way you write code today. What we would say is that our legacy code is monolithic. So it's a big glob of code, and it's hard to work on, it's hard to figure out, and it actually happened for some very good reasons. You know, we had so much success as a young company, we were growing so fast that we didn't know what we needed to build. So we were building it on the fly as we went, and you know, sooner or later you figure out, well, if we had known then what we know now, we would have done things a lot differently. And those kind of things start to compile. So today we find ourselves in a situation where we both want to add new features and functionality because we have, you know, a wish list that's a mile long. It extends out 3 or 4 years. And at the same time, we have older code, older user interfaces that are clunky that we want to modernize. And so you're trying to do both at once, and it's a balancing act. And we always say, and I'm sure you've heard this analogy, it's like changing the wings on the airplane while you're flying it. So that's the challenge that we have, and I think, frankly, most companies that I know have that same issue. I think there's always a question that companies need to ask about, should we buy or should we build? A lot of companies don't have the talent or the DNA or the budget to build. It's hard, it's risky, it takes longer than you think, and it costs twice as much as you think. And so when you build your own technology, you've got to go into it with your eyes wide open, and you've got to hire really smart people. And if you try to cut corners on talent, you'll fail. And even if you do everything right, you can still fail. But for some businesses like ours, you know, we think that technology is a key differentiator. The reason that I like proprietary technology is because I would like to believe that we have proprietary processes. So we figured out how we want to do freight brokerage. You know, we want to do multimodal, so it means we do full truckload, we do LTL, we do intermodal. We also want to do managed transportation, where companies outsource the transportation function to us, so we have to have capabilities around that. You know, how do we mark it up? How do we make money? How do we charge them? How do we audit? And then over the years, we say, oh, we want to add data science to the equation, so how do we integrate that? And so for us, buying something off the shelf feels like we wouldn't be able to run the business the way we want to run it. Now, if I'm an LTL trucking company and I'm not used to spending a lot of money on technology and I don't have any talented technology people, it's probably not an option. I need to go out and find a good package off the shelf and a good implementation consultant that can put it in. So that's kind of how I balance buy versus build. And even today at Echo, I mean, even though we consider ourselves a tech company and we have a lot of IT talent, there's certain things that we don't want to build. We just say, why build it when you can rent it? And so we do a lot of that. So presently at Echo, some of the things that we have going on, I mentioned the multiple integrations. We have, you hear about these freight marketplaces. Well, we have our own freight marketplace. We have enough volume, with 18,000 shipments a day, that we get a good view of the market every single day. And we also have gamified how we source capacity so that we have internal competition from our people that source capacity to book the load. And we think for us that optimizes each and every shipment for service and for gross margin, and we believe it makes us more profitable than our competitors, and we believe that we have a better service than our competitors. We've got carrier apps and shipper apps, both web-based portals and mobile apps. I'm not convinced that those are the answer because in the case of mobile apps for drivers, if I'm a driver and I've got 15 different mobile apps, am I really going to use 15 mobile apps? I'm probably going to use the one that I get loads from, but then if I try one and it doesn't work, I'm going to stop using it. We have more success with getting dispatchers to use our portal. But most of the people in our business are doing mobile apps. We think about our technology really in three realms. We think about client technology, we think about carrier technology, and then we think about internal efficiency. And I think for the most part, in this moment in time, we've done pretty much everything that the shippers want us to do. And in fact, a lot of times we do more than they want us to do and we can't get them to use what we've made. And with carriers, that's especially true. We deal with a lot of small trucking companies, and I'm convinced they run their business on a whiteboard, or at best Excel. And so, trying to get some of these trucking companies to engage and use technology is sort of like pulling hen's teeth. And that's why in our strategy, we talk about, one of our marketing mottos is, technology at your fingertips and experts by your side, because, we think that technology in our industry exists on a spectrum with the very sophisticated, Anheuser-Busch, Target, these companies that demand a status update on their shipment every 10 minutes, to, the dispatcher that's writing on a whiteboard, or the shipper that's handing you paper bills of lading. So our strategy has been, we've got to have the people aspect of the business and value the relationships, but simultaneously we have to have the tech to meet that spectrum of sophistication wherever they are on the spectrum. And that's worked out well for us. Internal efficiency, I talked about that. That's probably where we spend the most money right now. And it's the technology that nobody gets to see, because it's all about how do we become more efficient? How do we take a person that's booking 15 loads a day and get them to book 45 loads a day? Because if we can do that, we get huge operating leverage. And by the way, that person will make a lot more money. And we think it's there. We think that through the application of data science, and I'll talk more about some of that in a few minutes, through better user interfaces, through better integrations with shippers and carriers, we can dramatically improve the productivity of our people as much as 3x. And that's huge in any business. So internal efficiency is a big focus of our technology investment. In the LTL community, there seems to be a move now to something that's known as dynamic rating. So I talked earlier about the archaic method of rating LTL shipments, and LTL carriers will create a tariff and they'll give it to you, and this is your price, and they keep that price constant for the next 12 months, sometimes longer, before they take a rate increase. Or in a market like this, they'll take a rate decrease because they're looking for more freight. but they're very static rates. And suddenly there's a few carriers out there that are saying, you know, we can do better than this. And when you run in the LTL business, and I spent a lot of my career in LTL, there's one way that you make money. It's utilizing the capacity of your network and keeping your network full and charging as much per pound as you can. And if you do those two things, like Old Dominion does, you make a lot of money. And so for the life of me, I couldn't understand why carriers didn't come to the table sooner to work with people like us. You know, we give LTL carriers $1.2 billion a year in revenue. And we have the technology, we give the data, we tell them more about their business than they know. And now they're coming around to the fact that, okay, we're gonna treat you as a sales channel, Echo. We're gonna treat you like a spigot. Where we want more freight, we're gonna open up the spigot, let more freight come into our network. Where we want less freight, we're gonna close the spigot, and you can give it to somebody else. And dynamic pricing is the tool by which they can do that. So instead of us pinging the SMC3 rate API that we would use today, or the tariffs that we have loaded in our system, we'll ping the carrier directly. They'll give us a rate in real time, and it might be a rate that's better than market if they need freight in that lane at that moment, or it might be a rate that's higher than market if they don't need freight in that lane at that moment. And it's a really smart move on the part of the LTL carriers to take advantage of that with a partner like us that has a lot of freight that we can give them. Because utilizing that network is their key to making money. One of the things you hear about a lot in transportation today with shippers is about visibility. I want visibility. You know, I want to see where my freight is every minute of the day. I want pretty graphics and reports that, you know, give me visual information and business intelligence. And so I think most companies are doing that. Third-party integrators are doing a lot of that. So, you know, we're being requested by our clients to connect with somebody that they're connected to so that they can get data from us in a format that they want, and we're happy to do that. And that's becoming more and more prevalent. And these I call them third-party utilities. You know, they provide a piece of technology that does something very specialized that people like us don't really want to build, you know. So they build it, we use it, the customer uses it, everybody's happy. So I think that's been a good thing to the industry. Blockchain is another technology that's out there, and I'll tell you I'm a little biased. First of all, I am a blockchain fan. Some of you know from one of my previous talks that I mine cryptocurrency. It's kind of a hobby business. So I'm quite well informed about blockchain and cryptography and how all of that works. And when the industry started talking about using blockchain for supply chain, I kind of shook my head and said, this sounds like a solution in search of a problem. And I don't want to disparage it because people like Walmart are using blockchain to track groceries and food from farm to shelf. IBM's got a blockchain product. Maersk has a blockchain product. FedEx and UPS use blockchain products. But I don't get it because one of the chief reasons for using a blockchain database to store information is it cannot be altered and it can help prevent fraud. I just can't think of once in my career where anybody created fraud on a shipment status. So, you know, it just doesn't seem that important to me. So I'm sure there's people in the audience that are fans of blockchain for supply chain, and you know, I'd be happy to discuss it with you later, but it's a technology, it's out there, some people are using it, I just don't get it. What I do get though, I work with a VC out in Silicon Valley, and occasionally when they make an investment, they'll ask me to look at the company. And so I got invited to meet with a CEO of a company out there. And the company was called Trackonomy. And they said, yeah, check it out. You know, we want to see what you think. You know, maybe you'll have some ideas how this technology can be used. And, you know, maybe if you want to invest with us, you can. So I said, okay. So I went out to San Francisco one day, and I go into the Starbucks in San Bruno. And I sit down waiting for this guy, and this little Dutch guy with a beard and a really old briefcase shows up, and we introduce each other, and I really don't know anything about what he's doing, so I said, "What are you doing?" So he opens up his briefcase, and he pulls out a roll of duct tape, and he sets it on the table. And I said, "You make duct tape?" He goes, "Yeah, but it's not duct tape." I go, "What is it?" So he takes that duct tape and he tears off a piece about this long and he sticks it on the table. And I said, well, first of all, let me give you his background. He had a PhD from Stanford in electrical engineering. He was a professor at Stanford. He left academia and went to work for Flextronics. And Flextronics makes, as he said it, they make things thin. In my conversation, I was asking about some of the work he did at Flextronics. He says, "Well, you know those Apple AirBuds?" I go, "Yeah." He goes, "I invented those." And he goes, "You know that touch screen on your Apple iPhone?" He goes, "I invented that." I go, "Okay, this guy's pretty smart." So back to the duct tape, I said, "So you made duct tape?" And he says, "Well, in this piece of duct tape, there's a telephone. There's a GPS. There's an accelerometer that can detect motion. There's a temperature gauge. If I want, I can put a microphone in it, and it's got a battery that will run it for 5 months." And I said, "Wow, what's the use case?" He said, "Well, I think it's supply chain." He said, "For instance," he says, "every piece of tape on this roll, I can program it to do whatever I want it to do." And I said, "How do you program it?" And he said, "I send it a text message." It's got a telephone in it. I said, "So that roll of tape has a whole bunch of telephone numbers in it?" And he goes, "Yep." And he said, "So I can stick this tape on a box, put it in a warehouse, and I can code that piece of tape that if it ever moves, to wake up, call home, and report that it's been moved." And at the time, I said, "Well, what's the cost per unit?" And he said, "It's about $10, but we'll get the price down under $2 before too long." And I invested in that company, by the way. And one of his biggest customers now is UPS. And every COVID vaccine that UPS shipped had a piece of Traconomy tape on it. So when you want to talk about supply chain visibility, there's technologies that are emerging that are just out of this world. In 2014, I was pondering the world, and I thought about Amazon, thought about Netflix, thought about all these tech companies that use data and how smart they are and how well informed they are about the behaviors of their customers. Netflix knows what kind of movies you like. Spotify knows what kind of music you like. Amazon knows what you were talking about when Alexa overheard you. So I thought, well, we have a lot of data. We should be doing that stuff. So at the time, I went to my CFO and my COO. Some of you guys know them. They're both they're recovering accountants. And accountants by nature are very conservative, and their idea of math is when all the columns add up and foot, right? And me with having a statistics background, I said, well, that's not real math, So I said, what if we hire some people that have master's degrees or PhDs in mathematics and work on our data? And my two finance guys said, why would you do that? And they said, we have great accounting here. We have great systems in place. I said, well, you would do it because you could optimize the business. You could optimize the margin on every transaction. You could optimize the service. You could understand your customers better. And they said, there's no need to do that. Our business is already optimized. And I said, well, how is it optimized? And they said, well, we pay commissions. So our salespeople and our carrier salespeople, their goals are aligned with ours because their goal is to make the most money they can on every shipment, which is good for them and it's good for the company. And I said, they're not smart enough to optimize on every shipment because they don't know what they don't know. So this argument went on for about 6 months, and finally, I kept giving them the hint and they wouldn't take it. So finally, I took matters into my own hand, and I hired this bald-headed guy right here. Scott Friesen, who's our EVP of, it's data science, we call it strategic analytics. And I stole Scott, well, he originally worked at Best Buy, where he worked in the business insights department. And he was the guy at Best Buy that figured out that they made more money selling insurance than they did electronics. And you know, you've probably seen that if you went into a Best Buy store. Then he went from there, he went to Ulta Beauty Supply, and he worked with what they call behavioral economics. And if you've ever read the book Nudge, it'll give you a good feeling for what that's about. But he was telling me all these amazing things, like if you put the Maybelline display on the right-hand side of the cash register, sales will be 8% higher than if you put it on the left-hand side. I said, well, how can that be? And he said, I don't know, but it happens and it's in the data and I can prove it, you know? And so I said, I gotta have this guy. So Scott came to work for us and I said, okay, I want you to take 2 months. You don't have anything to do for 2 months. All I want you to do is walk around, meet people, ask what they do, watch how they do it, learn the business, and at the end of 2 months, come back and talk to me and tell me what you think you can do with your skill set. So 2 months later, Scott came back, and he had a list with 26 items on it. I think today, that was what, 9 years ago? I think we've only done seven of the items on the list so far. So it's a target-rich environment. Am I okay on time? Okay. And so today, we use data analytics to do a lot of things. We have algorithmic truckload pricing, and when it comes to algorithms, I have a saying, algorithms are only good if they're good. What that means is if you've got an algorithm that predicts a price, like the market price of a truckload in an OD pair, if it quotes a price that's too high, you're not going to win the load. And if it quotes a price that's too low, you're going to lose money on the load. So it's got to be just right. And we look at our models and we use a measurement called MAPE, mean, average, percentage, what is it, Scott? Yeah, there you go. And we check the variance on each individual prediction to the actual price in the real world. Because you can take a total, and I can take all my predicted prices, and I can take all my actual prices, and they can be dead on equal. But the individual variance by quote could be 5, 10, 15% off. So we're constantly perfecting our pricing algorithms, and we're up to version 5 after many, many years of doing that. We have a load matching algorithm, so for every load that comes in, we know who are the best carriers to give it to based on their known backhaul lanes. We know the prices that they've charged us in the past. If our pricing algorithm says we ought to pay them $1,000, but we know that they took it last week for $850, we'll offer them $850. You know, so we're pretty smart about how we manage our pricing because the system allows us to do that. We have buy it now pricing, so when we push loads out to our app or our portal or to a dispatcher somewhere, we say, here's the loads that are available, and just like you know, Amazon or you know, some of the e-commerce sites, there's a buy it now price. They can click the button and it's their load. And our analytics have allowed us to create, and we just released this, automatic negotiation. So if they don't like our buy it now price, they can submit their own price, and we can counter it or we can accept it, and all that happens automatically. We also look at things like price elasticity. So for you econ majors out there, we understand for each individual shipper how sensitive they are to price relative to the service that they want. So we know that on customer X, if we want a 96% probability of winning the quote, we can only have so much margin. And customer Y, you know, they're not as sensitive, they're more concerned with service, and so that informs how we price on an individual transaction basis, customer by customer. Likewise, we can do the same thing with carriers. We know the price sensitivity of carriers. Funny fact, I was talking to somebody about this today. You know, we deal with 50,000 trucking companies. We deal with the largest trucking companies that you know. I think one of them's in the room. And we deal with owner-operators. And everybody thinks the owner-operators are going to have the cheapest price. but they actually have the most expensive price. And we've proven that time and time again. So anyway, we have a lot of analytics that goes about how we do our matching to optimize for both service for our clients and for cost and margin for us. We also look at price elasticity in terms of customers' perceptions of the brand of the carriers that we use. So for instance, I'll tell this story because they don't really exist anymore. I was dealing with Jack Holmes from UPS Freight, and Jack came into my office one day, and he's retired, so he wouldn't mind me telling this story. And he said, Doug, he says, we want more freight. And I go, okay, happy to give it to you, but you need to lower your price a little bit because you're not competitive. And he says, what do you mean? We're the brown shield. And I said, well, you may be the brown shield, but you're too expensive and people don't pick you. And he goes, what do you mean? And so I pulled out the report and I said, UPS Freight is 10% higher 86% of the time, and when that happens, you get selected 4% of the time. So people aren't willing to pay what you think they should for the brown shield. And that was very informative for him because he had a perception or an ego or something for his brand that was different than the customer's perception. So we actually work with a lot of LTL carriers, and we inform them and we give them data because we have customers that route shipments in our technology, and we have employees that route shipments in our technology, and we don't tell them who to pick. So they make those decisions, and in aggregate, we can evaluate all that data and come to conclusions about how people perceive brands and service relative to the price that they're paying. We also have a prototype for something we call Echo Tours. Echo Tours is where a dispatcher or driver says, hey, I'm in St. Louis, it's Monday, I want to be on the road for the next 5 days, I want to get as many miles as I can, but I need to be home next Friday at 5 o'clock for my son's birthday party. And driver satisfaction is a really big issue in our industry right now. You know, it's hard to find drivers, it's hard to keep drivers, so trucking companies will do whatever they can to improve the quality of life for drivers, and this is our way of helping. So we have an algorithm that says, okay, we'll create a sequence of trips. Before we even know what they are, we'll make a commitment to you that we'll give you X number of miles, we'll have you home by Friday, and you're going to get an average rate of pay that's higher than what you want and lower than what we want. So it's kind of a win-win for everybody. It's a quality of life issue for the driver, maximize their miles, they get a rate per mile that they can live with, and we get a blended rate per mile that's better than we would otherwise pay. We use a number of technologies for data science. You know, a lot of it's good old-fashioned statistics. We do some work with neural networks. We use geospatial autocorrelation mapping. So for geographic points where we don't have enough data, it's a way of estimating points that we don't have the data for. And we use graph databases, which is a different way of storing data. If you think about Facebook, and Facebook, you've got all these people, they're little circles, and they're connected to other circles, and they would call that a social graph. There's a lot of data that lives in that format, and graph databases are a way that you can quickly access data, you can alter the database quickly, and it's got some advantages over traditional relational databases. So that's kind of the present world. Now I'm going to look into the future a little bit, and I would say, you know, hardware is maturing at very fast rates, software is maturing. The next big opportunity, I think, is merging technology with data science. So it's sort of what I've been talking about. You know, I'd like to think that we're on the leading edge of that. And the way that we do it is, it starts with a hypothesis. We have some idea that there might be a pattern that exists, or a pattern that could be detected that a human doesn't see. And we take that hypothesis, and Scott and his team, he's got 17 people in our analytics department. They've got an R&D space with data and tools, and so they'll take that hypothesis and they'll test it with real-world data, sort of in the laboratory. And you know, if the numbers work out and the MAPE is low enough, they will create a prototype. And then the prototype's usually kind of kludgy. It might be some PDF documents, and we make some poor broker do his job and then look at the PDF documents. Or we might create a little website for them to get some information. But ultimately, if it works and we like it, we have to put it into production, which means now we have to take those algorithms, those formulas, and we have to hand it to our IT engineers and have them build it into our system so that when our users are using the system, they actually get the guidance that the data science provides. So it's pretty tricky to figure out how to do that, but it's very powerful when you do. And I think that's where the world's got to head. Some of the things that we're working on going forward is, like I said earlier, the 5th version of our truckload pricing algorithm. We're coming up with a new algorithm that prices partial truckloads, so shipments that were technically large LTL shipments and don't take up a full truck, but we can combine them with other LTL shipments. We're prototyping geolocation data so that we can track weather events and predict when weather will impact the arrival time of a truck and whether or not it will miss its appointment. This is important for service considerations. And then I think this one's really exciting. Natural language processing technology, NLP. Today, Echo, we get 1 million emails a day inbound. Of those 1 million emails, about 30,000 of them are requests for a rate quote, and another 31,000 are requests for a shipment status. And we believe through using natural language processing that we can have an AI that reads those emails, determines what they're asking for, and takes an action, gives a response, whatever, without any human intervention. And just to tell you what that means, so the 30,000 plus the 31,000 at 3 minutes per email saves us 3,000 person hours per day. And that's just 60,000 out of 1 million emails we get. Then when you start looking at accounts receivable and accounts payable and other departments that generate a lot of email traffic, there's huge opportunity to let the AIs read the emails. So that's something that we're sort of in R&D on right now. There's tools out there. We're looking at the tools. We're also looking at building it in-house, and we haven't made that decision yet. The next thing I want to talk about is just sort of more general AI. I'd like to just take a quick poll. Raise your hand if you've heard of ChatGPT. Okay, good. I kind of expected that. Now, raise your hand if you've actually used ChatGPT. Pretty good. This is probably the thing I'm the most excited about. That's not the only platform. Google came out with Bard. There's another company called Anthropic that has a product called Claude. Claude's actually pretty interesting. The people that built that came from OpenAI, which built ChatGPT. And they came about it purely from a safety point of view. So they have what they call constitutional AI. If you've played with ChatGPT, you find sometimes you ask it things and it gives you crazy answers. I actually find that it lies sometimes. I've asked questions before, and it's given me an answer that I know is wrong, and then I challenge it, and it says, "Oh, I apologize. I told you wrong." I mean, it literally says to me, and I had Bard once tell me that it made something up. So I don't think it's perfected yet, but they're making progress every week. About a month ago, I asked ChatGPT to write a poem about Joe Biden. And it wrote me this beautiful poem about Joe Biden and how wonderful he was, what a great leader he was. I said, okay, that's pretty good. It rhymed. So they said, write me a poem about Donald Trump. And oh my God, was it nasty. I mean, it was ugly. And so then I challenged it. I said, well, that was kind of mean. Like, why are you so hard on Donald Trump? And then it defended its poem. It said, well, he's a bad guy, and he did all these bad things. And so I said, okay, well, I guess, And then about that same time, I'm watching the news, and there's all these complaints coming in from conservatives that's saying, ChatGPT is woke. So I agreed. But I tried it again last week, and the poem that it wrote for me about Donald Trump was so beautiful that somebody reprogrammed it. So it's not woke anymore. A couple of interesting facts. So these chat AIs are what they call large language models, and it's kind of like, think about if you read everything in the internet for the last 5 years and you could remember it. That's kind of what they do, except they read books, they train these models with all sorts of different data. And I won't explain how a neural network works, but to say that neural networks have these things called nodes that are like little calculator machines, and they take inputs and they make a calculation, and depending on what they get, they'll send the information to one or more other nodes in a different layer. And that, the analogy is that they model it after how a human brain works, and that the nodes are like neurons, and they call them neurons, and the connections with other nodes are called synapses, so just like the human brain. And for each synapse, they put a weight factor on it, which is called a parameter. And so when they train the model and they're running data through it, they keep adjusting the parameters until the output equals what it should equal. So the second version of ChatGPT, GPT-2, had 1.4 billion parameters. So think about, like, if you remember regression analysis from college statistics, you have, each variable has a coefficient. Well, ChatGPT had 1.4 billion coefficients. But ChatGPT-3, the next version, the one they released a couple months ago, had 175 billion parameters. And ChatGPT-4, which came out a few weeks ago, they won't tell us yet how many parameters it has, but it's estimated by people who are pretty smart that it's got over 1 trillion parameters. So these things are getting smarter and smarter, literally by the week, and people are trying to figure out what to do with them. So one of the companies I just mentioned, Anthropic, they have a unique idea, which is your company can license their large language model, and you can supplement it with your own proprietary data. So in our case, we could have all the benefits of like a ChatGPT and have the whole world of knowledge at our fingertips, but we could also have all of Echo's knowledge. So if you've got a Slack application and all your IT people are talking to each other on Slack, that can all be building into your knowledge base. We use a product by Facebook called Workplace. It's kind of like an internal chatting system, and post pictures of your dog, and we have functional groups where we talk about the business. All that knowledge, all that communication can be gathered up and supplemented to the large language model, and you could from that create tremendous tools for customer service, for internal knowledge capture, for training your people. Some of the use cases are more advanced chatbots, ones that you don't have to program, they teach themselves. Sentiment analysis on inbound emails from customers, automated email response, data entry, predicting outcomes and trends. I've had ChatGPT look at a file and do statistics for me. You can do simplified data visualization, and even ask it to go in and look at all of its data and come back and recommend products and services that you should be offering your customers. And there's one more thing that it does really well, and that is it writes computer code. And so to demonstrate that, I made a little video because I didn't want to do it live. So you want to roll it?
I'm going to use ChatGPT to write some computer code in the Ruby programming language. For demonstration purposes, I'll create a simple application that reads data from a file, selects specific records, and performs some simple math and outputs the results. On my desktop, I have a data file called data.csv open in Excel. This is data from about 40,000 truckload shipments that I got from work. The first row is a header row that lists the names of each field or column. Each subsequent row represents a shipment, and for each shipment we have origin zip code, destination zip code, origin state, destination state, length of haul in miles, cost of the truck, cost per mile, revenue, revenue per mile, and gross profit. Scrolling down to the bottom, you can see that there were 39,872 shipments. Next, I have a simple text editor open where I have written a prompt that we will use to get ChatGPT to generate the code for our application. I'll summarize the prompt. Write a Ruby script that does the following. Read into an array data from a file called data.csv. The file has a header row, and then I list all the column names in the header. I specify that the zip codes need to be converted or truncated to the first 3 digits. Then I want to prompt the user to enter origin and destination as 3-digit zip codes. Next, search the data in the array and find all of the records that match the origin-destination combination. And if there are no matching records, print no matching records, try again, then return to the input prompt. For any matching records, first print the records as raw data, then print the number of matching records, average miles, average cost per mile, average revenue per mile, and average gross profit. Finally, return the user to the zip code input for the next query. Next, I will copy the prompt and paste it into the input window of ChatGPT. I click Enter to submit the prompt, and as you can see, ChatGPT is generating the code. At the end, it even gives us a description of how the script works. I will now copy and paste the code that was generated by ChatGPT into my text editor and save it as a file called rates.rb. This is our Ruby program. It's a simple text file with an RB extension, which the Ruby interpreter will recognize as a Ruby program. Now let's run the program. I'm using a terminal window to run the program from the command line. We're all used to the pretty windows in our desktop applications and websites, but behind the scenes, this is how all computer code looks and runs. I call Ruby followed by the file name. You can see that the program is working. It's prompting me for an origin zip code specified as 3 digits. I'll put 917, which is New York, and now prompted for the destination, I put 306, which is Georgia. It works. You can see that it listed the raw data for the 5 shipments that it found that matched my zip codes. It also produced the output that I asked for, which includes average miles, average cost per mile, average revenue per mile, and average gross profit. Let's try one more time. This time I'll put an Arizona zip in, 853, and a destination of 907 in California. Once again, we get our output. This time there are 18 matching shipments. In total, creating this application and successfully running it took about 3 minutes. It probably took another 5 minutes for me to write the prompt. Now, I could have written this program myself, but it would have taken a lot more time than 8 minutes, especially because I would most likely have to debug the code. And just to show you how flexible this technology is, ChatGPT can write code in multiple languages. Let's modify my script, and instead of the Ruby language, let's specify Python. Once again, I paste it into ChatGPT. It's generating the same application, but in a different language. In summary, we are in the early days of generative AI, having the capabilities of writing computer code. It's quite effective and very productive. I can only imagine where this technology will lead us in the next few years. Some of my thoughts include documenting existing legacy code, and improving that code, and even migrating it into more modern architectures or converting it into newer languages, and debugging newly written code. Thanks for watching.
So, I I have one small confession. When I ran that program, at first it didn't work. But through the magic of video editing, you don't know that, I got an error message. What's amazing is, so I copied the error message and I pasted it in ChatGPT and said, it didn't work. And it said, oh, I'm sorry. And it came back and it said, here's a different version of the code and this will work. And I put it in and it worked. So it was able to debug itself. So I was pretty impressed with that. That really kind of concludes my remarks and comments about my journey with technology in the transportation industry. So thanks for listening. I hope I didn't go too long, and I'll turn it back to Hani.
Thank you very much, Doug. Thank you. So we'll have time for a few questions. Okay, we have a couple of microphones.
Hello, I'm Maher, and I'm one of the PhD students here. So first of all, it's a breath of fresh air to see a CEO who's really into the weeds of data science, technology, programming, etc. So regarding clunkiness of code, processes, etc., I'm someone who's really into automation, optimizing it, and these things. And then you go work in the industry, and usually top down, they want results. It's results, results, results. And sometimes that conflicts with spending time on having these processes be automated, work efficiently, be more integrated with user input. So as someone who's more in the junior level, how do you kind of go back and forth with your superiors, your managers, your directors to explain to them the value of optimizing this piece of code or automating this process, or maybe spending a day or two extra delving into a problem to really get to the better results and have the process run faster and better over time rather than just focusing on results today?
Yeah, it's a good question, because a lot of IT managers don't want to be in the weeds. They want to manage, and they're trying to hit timelines and deadlines. But I think, you know, we depend on really smart software engineers who understand the details and the pitfalls, and we really depend on people like you to speak up and say, we can do this, but we're taking a shortcut and we're going to pay the price down the road. And so, you know, if we just invest a little more time and do it correctly, you know, it may cost more now, but it'll cost less later. And I think part of that is you educating your boss, who's probably not all that technical, the technical reasons why they should make that decision.
Thank you.
Doug, thanks for the coding lesson, first of all. That was awesome. How do you envision, like you talk about how the carriers are still, you know, at that base level, not at doing anything close to what you just showed? Like, how should they react? What should they be doing? How is this all going to become a mismatch with the speed of technology versus the speed of what's happening at ground level?
Yeah, I mean, I probably came off a little critical of asset-based carriers, and I shouldn't, because it's a really hard business. You know, I spent most of my career in LTL trucking, and it's hard. You're dealing with assets, you're dealing with laborers, you get phone calls at 2 o'clock in the morning that your driver just crashed and hurt somebody. So it's a very hard business, and they work hard for the money they make. I think they have to find the right combination of what can they build in-house and what should they build, you know, what should they buy from a third party. I think they should look at systems like Mastery, which, you know, because it's so much more modern than the systems that people are on, there's a lot more flexibility, and there's a capability to move fast. There's a capability to integrate with partners quicker. There's a capability to incorporate data science because it's all API based. You know, I talked about our legacy code and how it was monolithic. It's you know, I'll give you a silly example. Let's say that you're writing a program and you want to have a time zone conversion. Well, you should write that code one time. And everywhere in your program, that you need to convert at the time zone, you should call that one function and reuse that code. In a lot of systems, because they're in a hurry or because they're not disciplined, they'll write the time zone conversion function 50 different times in 50 different places. And then when something happens and they got to change it, they got to go find all the 50 places where they wrote that code, and they didn't even write it the same way everywhere. So, you know, that's what we call technical debt, right? So they have to find a way over time, and it's painful and it's expensive to pay off that technical debt, and they have to be smart about how they do it. I think they need to bring consultants in and help them evaluate their situation and what are the options and how to go forward.
Hi, my name is Spencer. I'm over here.
Oh, okay.
I'm an undergrad here. I have a quick question about the process of decision making of when you're deciding whether to kind of build a product yourself or outsource it. As you gave an example of using AI for like going through emails and sorting emails. And I'm wondering if you're kind of using mostly a cost basis or if there are other factors that kind of go into that kind of more modern decision making.
You mean for technology in general? Or
for
AI type technology?
I guess for technology in general, although specifically with newer technologies such as AI.
Well, first of all, you have to have a realistic assessment of your internal skill set, because a lot of the best and brightest technologists don't want to work in COBOL. So if you want to build in the latest hotshot language, Node.js or C# or whatever, and you want to be cloud-based and you're building new stuff, I always say that software engineers come in three flavors. There's builders, there's fixers, and there's maintainers. Maintainers just want to come to work 8 to 5 and fix the things that are broken and go home. Fixers like the challenge of fixing a problem, and builders want to build new stuff with the best and greatest tools they can get their hands on. If you're building new technology, you need builders. If you're running a mainframe that's using COBOL and RPG software, you need maintainers. So you got to have the right skill set. You got to give them, and to attract that tool set, you've got to have the right incentives. You have to have the right culture. You have to have the right environment. You have to have the right tool set. The best people want to work with the best stuff, and they want to build new stuff. And if you can do all that, then you have to assess, okay, what's the ROI on this project? You know, it's going to cost me $2 million to build it. What's the payback? How long does it take? How realistic are the timelines? Should I build it myself, or should I just pay $2,500 a month to P44 and rent it from them? You know, so those are the kind of things that we would look at to make that decision. When it comes to AI, you know, there's different types of AI. There's narrow AI that addresses a very simple problem like a truckload quote. And then there's general AI like ChatGPT. Very few people on the planet have the talent to create something like ChatGPT. So there's times where you got to know when you're out of your league.
Thank you.
I'm glad 10 years ago when we spoke, we were laughing at FedEx and UPS having a lot of legacy code. So finally you've come around and seen that whatever we built 10 or 12 years ago is also a legacy. But the question is, when we move to generative AI, how do you maintain your intellectual property and confidential information within the premise of generative AI and keep your differentiation in the market?
Well, to be clear, we haven't done it yet. I've had an initial conversation with the company, but the arrangement that they offer is you license their large language model, they will merge your own proprietary data with it, but they or nobody else can see your proprietary data. So you get what the rest of the world gets in their AI, but you supplement it with your proprietary data, which ostensibly makes you a little bit smarter about your business. You know, I've had one meeting with them, and I was intrigued by the idea, and I thought, you know, this has some really interesting use cases. You know, we haven't made a decision to do that yet.
I'm a faculty at Northwestern, and I wanted to know that if you see any role for the virtual reality, augmented reality, and metaverse in transportation.
You know, it's probably above my pay grade. I'm intrigued with some of the augmented reality, and you know, I've seen some sort of conceptual demos of it. But it's nothing that we've looked at to use. I'm sure there's probably a million use cases for it. We just haven't thought about it. Do you have some good ideas? I'd love to hear them.
Hi, I'm a PhD student in applied math at Northwestern, and I have a question about the interpretability versus usefulness of algorithms. That's kind of a debate in math, for example. So maybe you have a neural network or a machine learning algorithm that tells you, we observe this in the data, but we have no idea why, just some black box. Like, if you shift this display in Sephora from right to left, you get 8% more revenue. How beneficial is that compared to something that's perhaps less efficient, but that tells you exactly why this particular process is beneficial to your business?
Well, first of all, you're probably a lot smarter in math than I am, so I'm going to be cautious with my answer, and I'm going to look at my data science guy here. But we have instances where we get results and we don't understand why they are the results that they are, but they're accurate, and therefore, until they're not accurate, we tend to trust them. We still strive to understand what's the cause and the effect of it, but you know, like in the example I gave you about Ulta, you know, placement of their displays, the best I understood the story when Scott told me, they didn't really understand the reason why, but they liked the results.
Hi, good evening. I'm Alvin Chin from RXO. So my question has to deal with with all this technology you mentioned about and automation and ChatGPT. What now becomes the role that you see for humans? So number one, in terms of engineers, because I've heard, for example, with the way how ChatGPT is working, that probably maybe in 5 years or so, the actual existence of what a software engineer is or a developer is may be not like that anymore, right? So first of all, in terms of engineering, how that will affect engineering processes in the organization. And number two, in terms of the sales representatives, right? So those people that deal with the customers that say, I have a particular load or so, here are my requirements, what can you offer for me, in terms of, so would there still be a need for that type of human interaction? Yeah, thank you.
Sure. Well, in the case of engineers, I don't think you can let this write code unsupervised, right? You have, I see it more as a productivity tool. So, and there's a lot of talk now that the new emerging career opportunity is going to be prompt engineering, where you write the right prompt to get the result that you want, because there's a lot of nuance in how you write the prompt. But when I think about engineering, and I look at our own IT product roadmap, it goes out 5 or 6 years. And I can only spend so much money a year, therefore it goes out 5 or 6 years. I would love to be able to do it in half that time. And if I can make an engineer 2 or 3 or 10x more productive because I'm giving him a tool like ChatGPT and he can crank out the code faster, or she, I see it as a productivity enhancement in an area where we need enhanced productivity. And I really think the same logic applies to salespeople, right? We pay our salespeople on commission. We want them to sell as much as they can. We want to pay them as much as they can make, because when they make money, we make money. So anything we can do to make them more productive, to make them more effective, better communicators with their customers, more responsive, is going to be more money in their pocket and therefore more money in our pocket. So I look at it not as a replacement for humans, but as a productivity enhancement for humans. We consider ourselves a growth company, and even though we're approaching $4.5 billion of revenue, we don't want to slow down. And a lot of companies get to a size and the growth kind of tails off. But I think with these kinds of productivity tools, you can keep the growth trend going.
How you doing? I'm Brad Gillette. Thank you for being here. This is great. AI is really good at certain things. People are really good at certain things. But I think building on what you just said, you kind of beat me to it a little bit. Really, the ultimate solution is how they work together, right? AI is very good at logic and spitting out recommendations and conclusions. But it doesn't have reasoning, it doesn't have morals, it doesn't have business sense, things that people are really good at, feelings. How do you at Echo kind of balance those two things, kind of your data science outputs and your recommendations with kind of business sense and your experience that your team has?
Well, first of all, we haven't institutionalized the sort of the strong large model AI that ChatGPT represents. That's more my own experimentation. The AI that we use is, more like a small neural network that can predict a truckload price in a given lane, given a number of parameters like day of week, seasonality, time of day, what's the origin destination pair, what are the shipment requirements. So there's a number of parameters that would inform what we think the price ought to be. We also, we have a data that we look back in. We supplement with external data. So those seem pretty harmless. And frankly, a lot of our algorithms aren't AI. They're statistical. I mean, and Scott always says, when your only tool is a hammer, everything looked like a nail, right? A lot of times we get enamored with some of these fancy technologies and data science tools. And some of the tools we already have will do the job just fine. So for us, and I'm not an expert on this by any means, but we have an analytics team with 17 people, and they try to find the right tool to solve the problem at hand, whatever that tool may be.
So I get to ask the last question.
Okay.
And it's a two-part question. So first part is you've taken us through a very nice kind of overview, starting with the pager, how kind of revolutionary that was, to various technologies that that have made Echo a success. Was there some technologies along the way that kind of were flops, that did not quite live up to expectations, or that one may have invested in but didn't quite
At Echo specifically, or in my career?
Well, not necessarily at Echo, but just
Well, I'll tell a story. One time I did a small stint as a CIO in a small LTL carrier, and I reported to the owner of the company. And he said, I'm hiring you to be the president of the company, but before I make you president, I'm going to make you the CIO because I need a new computer system. And he says, when you get the computer system built, you can be the president. I said, okay, I'll take that challenge. So for the next 2 years, this was in 1998, we developed a TMS for an LTL carrier that was way ahead of its time. It was a relational database. It was written in Java. It was hosted on the servers. We deployed it through the internet. And it was, for 1998, it was very leading edge technology. And we decided to go with a big bang implementation, and instead of a parallel path. And when we flipped the switch on, it was really slow, and we couldn't invoice our customers for 6 weeks. Now, this company at the time was about $100 million in revenue, and when you can't invoice customers for 6 weeks, it can drive you into bankruptcy if you don't have good credit available. So, that was one of my, it ended up being a success eventually, but it's kind of also a lesson learned when you try to build your own stuff. It's hard. You're going to make mistakes. You're going to fail, and you got to fix it. In our case, we had no choice. If we didn't fix it, we would be out of business. And thank God the owner had good credit because he was able to supply the cash to keep us going. And ultimately, we fixed it, and it was a great system. I didn't get fired, and he made me president. So it worked out okay. But yeah, I mean, at Echo, we've had projects where, we've set out to build a particular application that did something. One of them was a truckload routing guide where, we do a waterfall tender to all of the participants of a routing guide, and we spent, a couple of years and several $1 million and used consultants, and when it was all done, we went, don't like it, doesn't work, it's not what we thought, start over, So there are false starts, there is wasted money, and that's kind of the price of being a technologist, is you're going to have some failures, and you got to learn from those lessons.
And so you've, again, enjoyed the whole variety of new discoveries along the way and taken advantage of blockchain and ChatGPT and so on. What is it that you think is really missing? What is your, if you had can you imagine something that is not quite available, but that could really be transformative? And I'm thinking in the context of, again, of the business.
Well, I think there needs to be a way for shippers in particular to bring more transportation automation into their business, because, like I said, I can't tell you how many transportation managers I've talked to in my career that said, I want this, technology, or I want a TMS, or I want to integrate with my carriers, but I can't get the budget, So I think, with the supply chain challenges that we had during COVID, it's woken up a lot of people. I think some of the digital startups, the so-called tech disruptors in our space over the last few years have actually been a very positive impact on shippers and carriers to wake up and say, we got to do more with technology. I just think in the last 5 or 6 years, the use of drivers using a mobile app. I mean, there was a period of time where drivers didn't want you to have their phone number. They didn't want to see you send them a text message. They certainly didn't want to put your app on their phone. And the industry has retrained them that that's how you do business now. So I think, I don't know if that's the answer to the question, Hani, but I think that getting better adoption from shippers, better adoption from trucking companies, and better adoption from the drivers themselves can accelerate the utilization of technology a great deal.
Please join me in thanking Doug Waggoner, our 41st annual Patterson speaker today. I always learn a lot at these lectures, and this was no exception. Thank you very much. Thank you for attendance and joining us today.